Most people watching this right now have spent the past week in what meteorologists are calling one of the most extreme heat events to hit the eastern United States since at least 2012. Triple-digit temperatures from the Mississippi Valley to the Atlantic coast. A heat dome so powerful, so expansive, and so stubborn that it turned the 4th of July holiday into a genuine survival exercise for hundreds of millions of Americans. New York City hit 100 degrees Fahrenheit on July the 2nd, its first triple-digit reading since 2012. Washington, D.C. reached 104. Boston climbed past 101. Actual temperatures running 10 to 20 degrees above the 30-year historical average. AccuWeather real field temperatures, the index that accounts for actual temperature, humidity, sunshine, and wind together, spending multiple hours per day between 100 and 115 degrees in dozens of states, stretching from the Mississippi Valley all the way to the Atlantic and Gulf coasts. Nearly half the United States, 180 million people, under a major or extreme heat risk designation from the National Weather Service simultaneously. More than 100 people treated for heat-related symptoms at a single outdoor event in Pennsylvania in one afternoon. The Great American State Fair on the National Mall in Washington, D.C. evacuated due to lightning on June 26th. America's 250th birthday celebrations reshaped and canceled across dozens of cities, not because of rain, not because of cold, not because of any of the weather hazards that outdoor event planners typically plan around, but because the furnace would not turn off. And now it is turning off. The heat dome is collapsing. And here is the twist that everyone who lived through this week's heat needs to understand before they exhale and assume the worst is over. The collapse of a heat dome of this magnitude does not happen quietly. It does not slip away on a gentle summer breeze. It goes out fighting. And the fight it picks on its way out is severe weather. Days of it across a corridor stretching from the northern plains through the Midwest and into the Northeast, with every ingredient that meteorologists require for dangerous, damaging storms already loaded and waiting in the atmosphere. This is the story of what just happened, what is happening right now as you watch this, and what is coming in the next 72 to 96 hours as the most powerful heat dome to grip the eastern United States in over a decade breaks down into one of the most widespread severe weather outbreaks of the summer. The threat is huge. The twist is that it comes wrapped inside the very cool air that everyone has been desperately waiting for. And understanding exactly how that works, the physics, the geography, the timing, and what it means for tens of millions of people directly in its path, is what this video is for. Let us start with the heat dome itself, because you cannot understand the severe weather threat that is about to arrive without understanding the extraordinary meteorological structure that created the heat and is now in the process of breaking down. A heat dome forms when a high-pressure system settles and strengthens over a region, trapping hot air beneath it like a lid on a pressure cooker. Normally, the atmosphere is in constant motion. Cool air pushing in from the north, weather systems rolling through every few days, the jet stream directing storm systems along a generally predictable path. A heat dome interrupts all of that. The high-pressure ridge diverts the jet stream, blocking the arrival of cooler air masses and deflecting storm systems around the edges of the dome rather than through it. The air beneath the dome heats through solar radiation during the day, cannot escape upward through the capping high pressure, and accumulates day after day like heat building inside a sealed greenhouse. The heat dome that settled over the central and eastern United States in the final week of June 2026 was, by any measurable standard, exceptional. Wikipedia's live updated article on the 2026 North American heat wave confirmed that the event struck starting in late June, with temperatures expected to reach between 100 and 110 degrees Fahrenheit across many areas. Climate scientists describe the heat dome as virtually impossible without fossil fuel-driven climate change, a phrase that appeared in coverage published July the 3rd by the Energy Mix, citing analysis of the event's relationship to long-term temperature baselines. The hottest temperatures, compared to historical averages across the eastern United States, were running 10 to 20 degrees above the 30-year mean, not 2 or 3 degrees. 10 to 20. That is an event of extraordinary statistical rarity, and it explains both the duration and the intensity of the heat that has been punishing the eastern half of the country. The human consequences accumulated quickly. In Canada, Ontario and Quebec faced orange and yellow heat warnings simultaneously, with temperatures reaching 37 degrees Celsius in humidex values, the Canadian equivalent of the heat index hitting 46 degrees Celsius in Ottawa on July the 1st. That is the equivalent of approximately 115 degrees Fahrenheit in terms of how it feels on the human body. The extreme heat in Ottawa generated massive instability that same evening. Large thunderstorms erupted over the region, and when they hit with everything the overloaded atmosphere had been building toward for days. Ottawa recorded 118 millimeters of rain in a single storm event, a staggering amount that overwhelmed drainage systems, flooded streets, and forced widespread cancellations of Canada Day celebrations in the National Capital Region. In Quebec, 100,000 homes supplied by Hydro-Quebec lost power on July the 2nd. By the following morning, 50,000 homes still had no electricity, with temperatures that remained dangerous for anyone without air conditioning. Back in the United States, the situation was equally striking. New York City's 100-degree reading on July the 2nd was its first since 2012, 14 years. Washington, D.C., Philadelphia, Boston, Baltimore. Every major city along the northeastern megalopolis recorded temperatures that placed significant portions of their populations at genuine medical risk. AccuWeather's senior meteorologists issued repeated warnings that staying hydrated was not simply advisable, but essential. That fluid loss through perspiration in these conditions could lead to heat exhaustion or heat stroke with surprising speed, and that local officials across dozens of states were being asked to set up cooling stations and ensure public access to water during outdoor events. And through all of this, the AccuWeather meteorologists had been watching something building on the western edge of the dome, a developing story that most people caught in the immediate misery of record heat had not yet focused on. Because the heat dome, for all its strength, for all its record temperatures and stubborn persistence, was beginning to show the first signs of breakdown. And the breakdown, when it came, was going to bring with it everything the dome had been keeping out. Here is the twist. And it requires a brief explanation of why heat dome collapses produce severe weather, because the mechanism is both counterintuitive and critically important for understanding what comes next. When a heat dome maintains its strength, the atmosphere beneath it is capped. That cap, the lid of high pressure, prevents the kind of vertical atmospheric motion that produces thunderstorms. Hot air near the surface wants to rise. The cap prevents it. The energy builds. Day after day, the surface heats further, the atmospheric instability grows, and all of that energy, meteorologists measure it in units called CAPE, or convective available potential energy, accumulates without release. When the cap breaks, all of that accumulated energy releases simultaneously, not gradually, all at once. And the amount of CAPE that is built beneath this particular heat dome over the course of a week of record temperatures across an enormous geographic area is extraordinary. The Storm Prediction Center's Day 1 outlook confirmed directly. Large CAPE values in the region exceeding 4,000 joules per kilogram over parts of the Central Plains, with moisture dew points running into the mid-70s, in some areas ahead of advancing storm systems. 4,000 joules per kilogram of CAPE is not merely sufficient for severe thunderstorms. It is the kind of energy loading that produces significant supercell thunderstorms, the rotating, long-lived storm structures that generate the most dangerous weather that the atmosphere is capable of producing. Large hail, damaging winds, and in the right circumstances, tornadoes. AccuWeather. Senior meteorologist Brett Anderson described the transition precisely. The cool down is coming to the Midwest and Northeast, but it will not be as substantial as what occurred in May and June. And then the critical sentence that contains the entire story. The transition will be marked by severe weather, including powerful storms with lightning and rounds of torrential rain that can lead to flash flooding, especially from parts of the Midwest to portions of the Northeast. The edges of the heat dome, the zone where the hot, humid, energy-loaded air mass inside the dome meets the advancing cooler, drier air mass pushing from the west and northwest, is where the atmosphere is most violently unstable. AccuWeather meteorologists confirmed the edges of the heat dome will be the most active for thunderstorms and the most likely zone for rounds of severe weather through the holiday weekend and into the days that follow. That edge is currently moving eastward as the dome breaks down, and everything in its path is carrying the full energetic load that a week of record heat has built up. Now let us look at the specific geography of this threat. Because while the severe weather corridor is broad, stretching from the northern plains through the Midwest and into the Northeast, the timing and character of the threat is different in different places. And understanding those differences is what allows people in the path of this system to prepare intelligently rather than just worry generally. The Storm Prediction Center's Day 4 through 8 outlook, published July the 3rd, identified organized severe thunderstorm development across parts of eastern Montana into the Dakotas as the first significant threat area early in the coming week. Supercell structures are expected across the Black Hills, with steep mid-level lapse rates promoting the risk of very large hail. Activity is expected to organize into a bowing MCS, a mesoscale convective system, during the evening hours and track roughly along the Nebraska-South Dakota border, with a risk of severe wind and large hail as it moves. That MCS, a cluster of thunderstorms that organize into a coherent, fast-moving line, is the signature storm structure of summer severe weather outbreaks in the central United States. A well-organized MCS can travel hundreds of miles overnight, maintaining itself through a self-perpetuating cycle of outflow winds that feed new convection at its leading edge, while old storms exhaust themselves behind. The people who experience a major MCS do not always see it coming the same way they see a tornado-warned supercell, the radar alarm, the sirens, the textbook imagery. Sometimes it arrives in the early hours of the morning as a roar of wind and a wall of rain that moves through in minutes, leaving downed trees, lost power, and damaged structures in its wake. Behind the initial Northern Plains outbreak, the next significant threat zone is the Central Plains and Midwest. The SPC's Day 1 outlook confirmed. Large Cape in the Iowa region, exceeding 4,000 joules per kilogram, with moderately strong southerly low-level winds maintaining a hot and humid air mass across southeast Nebraska, thunderstorms expected to intensify along pre-existing outflow boundaries by late afternoon, and the potential for supercells capable of large hail and damaging winds through the evening hours. A remnant outflow boundary tracking eastward across the Mississippi River into northern Illinois, with air mass dew points in the mid-70s and peak diurnal KP values expected to exceed 3,500 joules per kilogram, creates conditions for an upscale growing MCS capable of producing a swath of wind damage from northern Illinois into parts of Indiana, Michigan, and northwest Ohio by the evening hours. And then the Northeast, the most populated corridor in the United States, the most heat-stressed given the week it has just endured. The SPC noted that hot and humid conditions across the Northeast states, with full sunshine leading to steep, low-level lapse rates and moderate CAPE values, create an environment conditionally favorable for damaging winds in any convective clusters that can persist, even with weaker forcing than the Central Plains environment provides. The uncertainty in the Northeast, the forecasters noted, comes from the weak nature of the lifting mechanism. There may be fewer organized storm structures, but the environment is loaded enough that any cluster of storms that does manage to develop and persist will have the energy to produce damaging wind gusts and flash flooding. The Mid-Atlantic adds its own layer. Scattered damaging gusts are likely across portions of the Mid-Atlantic through the storm period. The southern lower Michigan area faces a swath of damaging to severe gusts from an approaching system. The Tennessee Valley remains in the picture for isolated to scattered severe storms extending from the northern and central plains into the Midwest corridor. This is not a localized event. This is a continental-scale severe weather outbreak driven by the collapse of a continental-scale heat dome, releasing a week's worth of accumulated atmospheric energy across a swath of the country that runs from the Canadian border to the Gulf of Mexico and from the Rockies to the Atlantic coast. There's a broader context to this event that makes it considerably more significant than a single summer severe weather outbreak, and that places what is happening right now inside one of the most unusual and consequential weather years in recent American history. The 2026 severe weather season did not start with the heat dome. It started before most people even thought about severe weather season. As of April the 19th, the National Weather Service office in Chicago reported that there had already been 11 individual thunderstorm events associated with at least one report of severe weather within their forecast area alone: tornadoes, damaging winds, damaging hail, or flash flooding, through roughly the first third of the year. The historical average for that period is approximately 4 days with severe weather, 11 events versus 4, nearly 3 times the average pace. The Storm Prediction Center had outlooked at least part of the Chicago forecast area for severe weather on 15 days so far in 2026 as of mid-April, including an unusual number of days at a level 3 enhanced risk or higher. AccuWeather's long-range summer forecast, published in May, identified severe weather as expected to be most active in June and July from the plains to the Midwest and Ohio Valley. The flooding zone to watch most closely, they specified, runs from Texas to the Ohio Valley, including the area of the Texas Hill Country that was devastated in 2025. The forecast projected that tornado reports might trend lower than 2025's extraordinary 1,000 to 544 preliminary reports, settling in the range of 1,050 to 1,250 for 2026, near the historical average of 1,225. But AccuWeather meteorologist Alex Duffus issued a warning that deserves to be sitting in front of every person living in the central or eastern United States right now. Do not let your guard down this severe weather season. Flash floods and damaging wind gusts can be just as destructive as tornadoes and often impact a much larger area. That warning has proven prophetic through the first half of 2026, and it is about to prove prophetic again. And layered beneath all of the individual event data is the biggest variable of all, the one that operates on a season-long timescale and will continue to influence weather across the United States through the rest of 2026 and into early 2027. El Niño is developing. AccuWeather's summer forecast confirmed that El Niño is expected to strengthen through the summer and could evolve into a rare super El Niño later in 2026, when it could have larger impacts on weather patterns across the United States in the final months of the year. El Niño, driven by anomalously warm sea surface temperatures in the central and eastern equatorial Pacific, influences the jet stream, shifts storm tracks, and alters precipitation patterns across North America in ways that are both predictable in direction and uncertain in magnitude. A strengthening El Niño in the second half of 2026 adds another layer of volatility to an already highly active year. Let us talk about what this all means in practical terms for people across the affected region. Because a weather forecast without safety information is only half of what people actually need, and this is a situation where preparation has real, measurable consequences. The immediate period, today through Tuesday, July the 7th, is the window of maximum risk across the broad corridor from the northern plains through the Midwest and into the Northeast. The atmosphere over this entire region is loaded with heat-generated energy that has been accumulating for days. The forcing mechanism, the cold front and associated upper-level trough pushing in from the west, is sufficient to trigger that energy in organized, potentially violent storm structures. The combination of CAPE values above 4,000 joules per kilogram, mid-level wind shear sufficient for supercell organization, and low-level moisture dew points in the 70s across the most volatile areas creates conditions that meteorologists classify as a significant outbreak environment. What that means practically for people in this corridor, flash flooding is the threat with the broadest reach. A week of dry soil followed by intense rainfall from slow-moving storm systems creates an environment where water runs off rather than soaking in, drains overwhelm quickly, and urban areas with impermeable surfaces like roads and parking lots can experience dangerous flooding from a single round of heavy thunderstorms. The SPC noted thunderstorm clusters with weak winds aloft suggesting slow storm movement. Slow-moving storms dump more rain on a single location over a longer period. If you live near a creek, a low-lying road, or an area with a history of flooding, the transition period out of this heat dome is not the time to test whether your usual route is passable during heavy rain. It has historically taken less than 1 foot of moving water to sweep a person off their feet and less than 2 feet to carry away most vehicles. Damaging wind gusts are the most likely severe weather threat across the largest geographic area. The MCS structures expected to develop, particularly the bowing line segments that form when a squall line accelerates into a fast-moving bow, are efficient wind damage producers. A well-organized bowing line can produce wind gusts of 60, 70, or more than 80 miles per hour across a swath of terrain hundreds of miles long. That is the kind of wind that takes down mature trees, snaps utility poles, and leaves hundreds of thousands of homes without power. In the current heat environment, a widespread power outage is not merely an inconvenience. For elderly residents, for people with medical conditions requiring powered equipment, and for communities without adequate cooling resources, losing air conditioning in 90 to 100-degree heat carries genuine medical risk. Quebec's experienced this past week. 100,000 homes losing power, 50,000 still without it the following morning, and temperatures with humidex values above 115 degrees Fahrenheit, is the precise scenario that emergency managers across the northeastern United States are monitoring as the system approaches. Large hail is the primary severe threat across the northern plains and northern Rockies corridor. The Black Hills supercell environment, with steep mid-level lapse rates and CAPE values loaded by the heat dome's eastern edge, is favorable for baseball-sized or larger hail. Large hail causes billions of dollars in property damage annually in the United States. The AccuWeather projection for 2026 identified the highest hail risk from Texas to Alabama, with another hotspot around Iowa, northern Missouri, eastern Nebraska, and northeastern Kansas, and the current outbreak environment encompasses several of those high-risk zones simultaneously. There is one more element to this story that deserves honest attention, because the heat dome that is now collapsing was not just a weather event. It was a human event, and the human dimensions of what 180 million people just lived through over the past week provide essential context for why the severe weather threat that follows the dome's collapse deserves to be taken seriously, not treated as a relief from the heat. America's 250th birthday was supposed to be a celebration of extraordinary scale. Festivals, concerts, fireworks displays, outdoor gatherings of every kind, across every corner of the country. The 2026 4th of July was one of the most anticipated national celebrations in a generation, the kind of event that draws people outdoors in numbers and with an enthusiasm that does not easily yield to weather warnings. And the heat dome forced real, difficult choices for organizers and attendees across the country. AccuWeather confirmed that America 250 events were being canceled and reshaped as the heat dome gripped the country. More than 100 people were treated for heat-related symptoms at a Pennsylvania outdoor event in a single afternoon. The Great American State Fair on the National Mall was evacuated due to lightning on June 26th, before the heat dome even reached its peak intensity. All of that context matters because the people who are about to be in the path of the severe weather outbreak that follows the dome's collapse are the same people who just spent a week dealing with extreme heat. Fatigue is a real factor in severe weather preparedness. Heat exhaustion impairs judgment. Communities that have been focused for a week on heat safety protocols, cooling stations, and power grid stability need to simultaneously pivot to severe weather protocols, flash flood awareness, shelter locations, backup power and communication systems in a matter of hours as the atmospheric pattern flips from one extreme to the other. Emergency management systems that have been deployed for a heat event need to redeploy for a severe weather event. And individual households that may have already experienced stress, power disruptions, or health impacts from the heat are now facing the additional challenge of the storms that the heat created. The big picture of the 2026 summer weather pattern is, in the most accurate and honest sense, a pattern of extremes. The same summer season that produced the worst tornado season in 14 years in 2025, 1,544 preliminary tornado reports, is now producing in 2026 a heat dome that National Weather Service classified as affecting 180 million people simultaneously, followed within days by a multi-day severe weather outbreak across the most populated corridors of the country, a developing El Niño that forecasters believe may evolve into a super El Niño by the end of the year. Wildfire threat elevated across the Northwest, Great Basin, and Four Corners region, drought worsening in the Northwest, Northern California, and parts of the Gulf Coast and Southeast, flooding risk running from Texas to the Ohio Valley. The entire range of atmospheric hazards simultaneously elevated, simultaneously active, simultaneously demanding attention from forecasters, emergency managers, and individuals who are trying to make safe decisions about where to be and what to prepare for. The severe weather threat that is coming in the next several days is not separate from the heat that just occurred. It is the heat's successor. The same energy that built for a week under the dome now releases in days of storms. The same atmospheric instability that produced record humidex values in Ottawa and record temperatures in New York is about to produce damaging wind gusts, large hail, torrential rain, and flash flooding across a broad corridor stretching from the Dakotas to the eastern seaboard. The threat is huge. The twist is that it arrives wrapped inside the relief. The cool air everyone has been desperately waiting for comes in, and the price it charges for its arrival is measured in the storms that ride its leading edge. Here is what you need to know as of right now, July the 5th, 2026. The heat dome is collapsing. The collapse is real, it is measurable, and it is being confirmed by every major forecast model and every weather agency tracking the system. The cool down is coming, but before it arrives, wrapped inside the very atmospheric transition that brings the lower temperatures, a multi-day severe weather outbreak is unfolding across a corridor from the northern plains through the Midwest and into the Northeast. The energy available to fuel those storms is extraordinary. A week of record heat loading the atmosphere with CAPE values above 4,000 joules per kilogram in some areas. Low-level moisture with dew points running into the mid-70s. Sufficient wind shear to organize supercell structures capable of producing very large hail. MCS development likely to produce swaths of damaging wind gusts across hundreds of miles. Flash flooding risk from slow-moving high-precipitation storm cells across areas that have been baked by a week of extreme heat and may have dried soils at the surface while maintaining saturated subsoils that cannot absorb additional rainfall quickly. This is the forecast. It is based on verified data from the Storm Prediction Center, AccuWeather, the National Weather Service, and real-time atmospheric observations as of today. It will evolve over the next 72 to 96 hours as the system develops and meteorologists refine their understanding of exactly where and when the most significant storms will occur. Track the forecast. Check the official National Weather Service forecast for your specific location. Know where your shelter is, not just from tornadoes, but from lightning, from flash flooding, and from the damaging wind gusts that a major MCS can produce without warning. Keep your phone charged and your weather alerts activated. The heat is ending. But it is not leaving quietly. And the twist in this story, the severe weather riding in on the back of the cool down everyone has been waiting for, is the part that has meteorologists watching this setup with the kind of focused attention that the atmosphere demands when a record-shattering heat dome decides to break down across 180 million people all at once. Stay alert, stay informed, and stay safe.